So today, we're going to talk about how to solve linear equations. And we've been doing this for years, really. I mean, all the way back to Algebra 1, we've talked about solving linear equations. But we're going to look at all types today. So we're going to do variable on one side, variable on both sides. We're going to do some ones with some parentheses where we have to do distributive properties. So there's going to be a lot of different variations of equations that I'm going to kind of go after and show you. And then at the end, we're going to do some where we call literal equations, where it's kind of like a formula, where it's a bunch of variables and we have to solve for like a specific variable. So just a lot of different types that we're going to see today. Okay, first one is one variable on one side. Those are pretty straightforward. 2x minus 9 equals 5. When you first started doing these, you probably called it a two-step equation, because really we just have two steps to get this by itself. Our goal is to solve for x. What are we going to do first? Add 9, okay? Whatever is not connected with the x directly is what we're going to start off with first. So we're going to add 9 first. And then to finish out for the 2, remember there's a multiplication sign assumed to be between there. We're going to divide by 2. And we get x equals 7. Okay. What I'll tell you from the very start today is that all of these problems are going to be equations. And so the good thing is I can check every single one of these. And in order to check it, I can take 7, I can plug it in. 2 times 7 is 14. 14 minus 9 should equal 5. And if it does, we're good, right? And so especially like on a quiz or a test, I'm going to keep telling you why not. Why would we not check it, right? Because then, especially if you have any doubts about if my answer looks right or feels right, then you can always plug it back in. And you shouldn't even have any question about if I got that question right or not, because I can plug it back in and show that it works. Okay, so that's a one variable, one side, pretty straightforward. Sometimes the variable might be on the right, would be the only different. Maybe I put the 5 on the left and the 2x minus 9 on the right, but it would still solve the same way and you would still get the same answer. Okay, the second one is where we have a variable on both sides. Okay, once again, our goal is to get x's together, to solve for x, right? But before I can solve for x, I got to get my x's together. And so I have a couple of options on a problem like this. I can either move the 2x over here, or I can move the 6x to the left. Doesn't really matter which direction we go. But what would probably be the better way to go here? Which one would be better to move? Probably the 2. And mainly, I like moving the 2 because it would keep my x's positive. If I subtract 6x from 2x, that would give me a negative number. That's just one more thing I got to worry about, right? So try to stay away from negatives if you can. And if I move my x's to the right, I'm going to move everything else to the left, which means I'm going to subtract 17. So I kind of like to do it where we combine 2 steps into one. Move the x's on one side, move the numbers on the other side. And then just really watch your signs. Probably the most common mistake here is just not paying attention to signs or leaving a sign off or whatever it might be. This is a negative 7 because it has a minus sign in front, so we treat it as a negative. So this would be like negative 7 minus 17, right? And so really, really watch your signs here. That would become negative 24. And then 6x minus 2x would be 4x. And then we divide by 4. And it's okay for your x to end up on the right-hand side when we're solving an equation. And you could either write it -6 equals x or x equals -6. It really doesn't matter because that's what we call the symmetric property, where those two are the same on either side, no matter which way you write it. -6 equals x, x equals -6. I could still check this one, and I won't check every single one of these, but if I were to take -6 in, the only difference here is I have to put it in for both x's. We have more than one x here. So 2 times -6 is -12. -12 minus 7 is -19. 6 times -6 is -36. -36 plus 17 is -19. So both sides end up equaling -19. So because both sides are equal, that tells me that -6 does work. Okay. And so still, once again, checking it is a great thing to be able to do just to verify that our solution works. Okay, so the first couple of examples are pretty straightforward. We've been doing a lot of those. You know, we do them in Algebra 1, we do them in Geometry, do them in Algebra 2, and so we've had lots and lots of practice. But then we get into some that have lots of steps to them. And obviously, the more steps that we have, the more mistakes that could be made, right? Makes it a little bit more difficult to get where we need to be. And there's just more things that could happen that could throw my answer off a little bit. It's kind of like order of operations, right? If we don't do everything exactly in the right order, then we're going to get an answer that's just a little bit different. Same thing for solving problems like this. If I do something out of order, I'm not going to get the correct answer and solve it for n. Okay, so as we look at this, what do you think we would do first? Distribute, right? Anytime I see parentheses, if I'm able to distribute, most of the time you'll be able to. There'll be some times where you might have some parentheses where you can't distribute. But most of the time, parentheses means probably going to distribute in some shape or form. Now, the first parenthesis has an imaginary like 1 in front of it because there's no number directly in front of the parentheses. So I treat that as like a -1. And here's where you got to be really careful. When I distribute, I'm distributing the negative with the 1. And so this would be 18 minus 3n plus 5. Okay, second side, same thing. We talked about this a little bit last week. We cannot combine these together because this is n and this is 4. Even if these both had an n on them, we still couldn't combine them, okay? Or if this did not have an n, and if it was just 11 minus 4, we have to distribute first. And once again, it's a -4 that we're distributing, not just a +4. So we're going to take this -4, because whatever sign is in front of it is going to stick with it. We're going to distribute that. So we've got 11n minus 4n minus 12. So all the way across, what we've done is we've gotten rid of all of our parentheses, right? Hey, what would be next? What do you guys think? Combine like terms, you bet. So we're going to look at the two sides, okay? We got the left side, we got the right side. Focus on each side one at a time. Over here, what can we combine on the left-hand side? 18 and 5, okay? Because they don't have any n's connected to them. So I'm going to leave the -3 alone, or -3n, I should say. And I'm going to combine 18 and 5. Same thing on the right-hand side. I'm going to combine my n's together, okay? And so 11n minus 4n would be 7n minus 12. And now we're kind of to the point where it's going to look very similar to one that we did a few minutes ago, where we have variables on both sides. We want to get those variables together. The one that would probably be a little bit better to move here would be the -3n, because then I can add it to the other side. And if I move my n's to the right, I'm going to move my numbers to the left. and we divide by 10. And there's a lot of different ways you could write your answer here. I'm okay with 3.5 here. There's nothing wrong with 3.5. Sometimes I don't always love decimals because sometimes we'll get like repeating decimals, right? And we don't necessarily want to write the answer as a repeating decimal. So I would probably lean towards writing our answer as a fraction because it's a little bit more exact. And so to get 7/2 here, I could have done 35 over 10 and then just reduced it. Okay. In this case, 5 would go into both of those. 5 goes into 35 7 times, 5 goes into 10 2 times, and that's where the 7/2 would come from. Okay. And so this would probably be the way that I would lean towards writing my answer, just to get in the habit of doing that every time. Okay. If you write 3.5, there's nothing wrong with it, but just got to watch out for like when we have repeating decimals and things like that, because we don't really want to round a repeating decimal. If I had like, let's say I had 3.6 repeating, 3.66666, a lot of times people will write it as like 3.67. Well, it's not exactly right, and the other reason why we got to watch out for that is because if I were to plug a number like that into my n, then it's not going to work, okay, because I rounded it, and a rounded answer is not going to satisfy the equation. So that's why we got to be really careful. We got to use the exact answer. And this one would not be an ideal one to check, right? Looking at this, I have to take 3.5. First of all, it's a decimal or a fraction. I got to plug it in for n. I got a couple of places, actually 3 places I would have to plug it in. It'd be a little bit of a work, right? And so some of these are a little bit easier to check than others. This would not be one that would be super easy to check. Is it still possible to check it? No doubt about it, but it'd be a little bit more work, okay? And that's why sometimes people lean towards not wanting to do that. Okay, we're going to do one more like that. I kind of throw this one in for a specific reason, because our answer kind of confuses people sometimes. Okay, so starting off, what we're going to do first here, same thing, right? We got parentheses. We got to think about this. We got to distribute it. So we're going to go boom. We got to go boom. And we're going to go 11 plus 5k minus 5. And then same thing as on the last one. If there's no number directly in front of the parenthesis, we're going to treat that as like a -1 right there. Or just distribute the negative throughout. I like to go ahead and put a 1 there, though. And then once again, watch your signs, because I have a -1 and a -6. So that's going to make this a +6. Okay, then we're going to combine things together. Okay, so 11 and 5. 11 minus 5 would be 6. Over here, I have -3k plus 6. Okay, and here's where it gets a little bit different. Okay, as we solve this one, we're still going to do just like we would any other time. We're going to get our k's together. And then we're going to subtract 6. So over here, I have 8k. On the right-hand side, we have 0. So what would our answer be here? Be 0, right? Because what we're saying here is, what can I multiply by 8 to get 0? It'd be 0, right? And the reason I kind of talk about this one is, a lot of people think, oh, they see that 0 and they think immediately like no solution. Well, we are going to have some no solution possibilities. But on this one here, if I were to take 0 divided by 8, I can get an answer of 0. 0 is a number just like any other number, okay? It's okay to have an answer of 0. Sometimes we freak out when we get 0 as an answer, but it's possible, okay? 0 is a number just like 8. And I could plug it back in up there and it should work as well. Okay, so it is a possibility sometimes to get an answer of 0. Okay, I'm going to do a couple of equations next, one with fractions and one with decimals. And I know it's not everybody's favorite, right? Sometimes we freak out sometimes when we see fractions, but I'm going to show you a really quick and easy way of solving an equation that otherwise would be pretty difficult to do, okay? And maybe you've learned this before, maybe not. How many of you guys would look at this equation and say, oh boy, that's going to be really hard to solve, right? Nobody? You guys love fractions? It's good to hear, right? Everybody loves fractions? Caleb, love fractions?
Yeah.
Yeah, it's your favorite thing, right? Yep. Now, you could use your calculator here, right? Okay, but I'm going to show you an easier way. Okay, and there's nothing wrong with the calculator. Because we have fractions, what we want to do is we want to change this from an equation that would probably be pretty difficult to do into one that's going to be a little bit easier. Okay, so as I look at my denominators, 5, 4, and 2, what is something, we call this an LCD, what is something that 5, 4, and 2 can all go into? 20, okay? So what we're going to do, once we find that number, okay, for all of the denominators, we're going to multiply all of those by 20. And you might think, oh boy, that's going to be really tough to do. But it's really not that bad, okay? Here's all you have to do. 20 times 1 is 20. 20 divided by 5 is 4. Okay. Did I even need my calculator for that? Hopefully not, right? Hopefully we can do some of that without our calculator. That'd be 4x. Okay, keep the minus sign. Now we're getting a little bit bigger. Maybe the calculator here. 20 times 3 is 60. Okay, 60 divided by 4. 15, okay? Or here would be an easier way to do it. 20 divided by 4, do the division first, would be 5, and then multiply it by 3, okay? So you can either multiply and then divide, or you could divide and then multiply. It works the same way, right? It gives me 15. Okay, here, 20 times 1 is 20. 20 divided by 2 is 10x. And finally, the last one doesn't have a fraction on it, so it's just 1 times 20, which is 20. So you guys now have a choice. I can choose to solve this equation with all these ugly fractions in it, or I can solve this one. Anybody want to do the top one? Okay, who wants to do the top one for me, just to check it? Hudson? Fractions? You want to do this one for me? Yeah? You love fractions, right? No? Ryler? No fractions? You'd rather do this one? Yeah. Okay. Shane? Ah, where's all my fraction people at?
Right here.
Jackson, you love fractions?
I already did.
You already did it? Okay. And you used just the top one? Did you use your calculator? No? And you just did, and did you change the denominator or no?
No.
Okay. What'd you get up there?
7 over 10x.
Okay. 7 over 10x. Okay.
7 over 10x.
Equals x, okay? So now let's solve this one down here. Let's see what happens, okay? Let's subtract 4x. Subtract 20. So this would be negative 35 equals 6x. And then all we got to do is divide by 6. Is there any way to reduce? Is there anything that goes into both 35 and 6? Yeah, so just think about some things that go into like 6. 2 goes into 6, right? Would 2 go into 35? No. 3 goes into 6. Does 3 go into 35? No. 6 definitely doesn't go in 35. Exactly. So that would be our answer, guys. Okay, negative 35 over 6. And I know that a lot of your calculators have fraction buttons and things like that on them, okay? And it's not wrong to like add 3/4 over here and subtract a half x, okay? There's nothing wrong with that if you want to use your fraction button, but still, like, as you go through it, you're really not understanding exactly what's going on because the fractions and common denominators and all that, okay? So for me, that would be the quickest and easiest way to approach a fraction problem on an equation. Much quicker and much easier, okay? Not quite as overwhelming when you see this equation as opposed to this equation. Even though they're the same thing, they're the same equation. Okay, we're going to do another one with decimals in here too. Okay, and I'll show you another trick on decimals that we can do. Once again, I know most of your calculators do decimals, and so if you just want to do it with decimals, there's nothing wrong with that, but once again, I feel like if you'd rather use nice whole number integer type numbers, then here's what we can do. Look at your decimal places. What do we call this decimal place right here, where the 4 is at? The tenths, right? So this is in the tenths. 25 is in the hundredths, right? So we're going to take the bigger of the two place values. So hundredths is more than tenths. So we're going to multiply by 100. So I'm going to take this entire equation and we're going to multiply by 100 because it's in the hundredths place. The hundredths is my biggest place value. So I'm going to write that down here so you know why we're using that. If, let's say, they were both, if this was just 0.4 and this was just 0.2 without the 5 here, then I would just multiply by 10 because tenths is my biggest place value, okay? Now, here's where sometimes this could get a little bit tricky. 100 times 0.4. If I take 0.4 times 100, what does that do to my decimal? Moves it how many places? If I take 8 times 100, what do I get? 800, right? Adds 2 zeros to the end. It moves it over 2 places, right? So if I had 0.08 times 100, it would just become 8. So 0.4 times 100 would become 40. Now, I don't need to distribute through the n minus 3 because I'm going to distribute the 40 here in just a second. So we're just going to multiply the number out in front of the parentheses. Over here, we're going to multiply both of these times 100 because they're not in parentheses. What's this here going to become? 25n. Yep. Just going to move it 2 places. What's the 6 become? 600. Yep. So we get a little bit bigger numbers here, but I feel like, once again, this is a better equation to solve than this. These two equations are the exact same equation, but this is going to be a little bit easier numbers to use. Once again, if you'd rather use the decimal button on your calculator, go for it. And you should still get the same result, but I kind of like to use these nice integer clean numbers than use decimals and fractions if we can. So I'm going to distribute the 40. Subtract 25 in. Add 120. And 720 divided by 15. What's that give me? 20? Oh, how much? 40 what?
48.
48. Okay, sorry, I didn't hear you. 48. Okay. So, kind of some uglier type equations with fractions and decimals, and I'm not going to give you a ton of those, but those are ones that we're going to see. Okay, if you take the AccuPlacer at the end of the semester, then you might see problems like that, where you're just kind of doing some basic algebra skills and some kind of like knowing common denominators and knowing fractions and knowing decimals and things like that. So that's why, you know, we try to cover some of those kind of things so you can get some of those skills. Okay, this next one here. We've done one like this already. We're going to go through and solve it, okay? So once again, you see parentheses, immediately we think we've got to do the distributive property. We're going to go 12x minus 8 plus 5. And we're going to distribute the minus 3. Combine like terms. Okay, and when we get to this point, what do we notice? Exactly the same, okay? So if I plug in 1 here and 1 here, I'm going to get the same answer, right? If I plug in 8 here and 8 here, I'm going to get the same answer, okay? So is there just one solution here? Is there just one number that's going to work? No, okay? What numbers are going to make this work? Yeah, anything, infinity, everything, okay? You can tell me any number, I can plug it in for x here, and it's going to work, okay? Everything's going to work. Okay. What you got? What am I factoring for? Like today, or taking some today?
It's just like,
No. Oh, okay. We'll have to like last one. When we do the project, when would you do the test? You have to do it on the day of the test. All right, so there's a lot of different ways that we can write this. All reals, okay? All real numbers, everything works, okay? This is also the word that they use for this in this textbook is called the identity, okay? If you have an identity, you kind of yourself, like we talked about the identity property, but this means everything. Everything works. Okay, and that's a little bit different than if I did one like this. And going back to this one over here, when I looked at this originally, there's no way for me to tell that this was going to be all real numbers, right? Because it's a big old long equation. So we have to do a little bit of work to get there. But once I see that the two sides are going to be exactly the same at any point in time, that's when I can go ahead and determine that it's going to be all reals. Well, on this one here, on the one on the right, we have 3x plus 3 minus 2 equals 3x minus 5. Okay, now really watch your signs here. This is 3 minus 2 on the left. Okay, are these two exactly the same? No, okay? But what will happen here is my x's are going to disappear, right? Because I subtract 3x from both sides, my x's are gone. And what I'm left with is 1 equals negative 5. Okay, when is that true? When will 1 be equal to negative 5? Be never, right? Hopefully we say never, right? Those two will never be equal to each other. Those two are not equal to each other. And so what do you think we would say here? No solution, okay? There is no number that I can plug in for x that's going to make these two sides equal, okay? So that's it. Those are two kind of special scenarios that we might see. Okay, the last thing that we're going to talk about here today, these are a little bit different. You've seen these a little bit as we've gone through, and basically a literal equation is usually a formula in some shape or form. And we might use this because maybe we have the length and we know how much area we have, and I want to figure out how much width I would need for like a dog pen or something like that, okay? And so I would want to figure out what the dimensions might be. So if I were to give you a formula of area equals length times width, that's a formula we've seen before, a rectangle, okay? Area equals length times width. And then what it's going to do is it's going to tell us to solve for W, which means we're getting W by itself. So to get W by itself, how would I get rid of the L? If I have L times W, how can I get rid of that L? Divide, yeah. Okay, just treat it like it's a number. And we're going to divide. But it's not a number, okay? So we're going to look at this and we're going to say A divided by L equals W. And that is our answer. Okay. It's a little bit weird, right? Because we don't have any numbers in there at all. We're used to solving and getting an answer of like x equals 8. Here, our answer is going to be an expression. And so it's going to look slightly different. All right, one other one here I'm going to show you. Okay, a little bit different formula here. What is happening with the P, the R, and the T? We're multiplying them, okay? And so I'm going to show you the easiest way to solve this one. So we're going to solve this one for T, which means I want to get T by itself. So what might happen is some people would say, I'm going to divide by P, and then I'm going to divide by R, but instead of dividing by them separately, I'm going to divide by PR all at once. And then that's how we would leave it. That formula is what we call the simple interest formula. It helps you to find like interest in like a savings account or something like that. So a lot of different formulas you could see, like maybe the area of a triangle or things like that, where you're solving for a specific variable. Okay. Assignment for today. So 10 to 46 by 4s, lots of different types of equations there. And then I just kind of picked some different ones out from the end here. Tried to pick out ones similar to the ones that we did on our notes. A little bit more problems than some days maybe, but there's just a lot of different types of equations here. I want to kind of make sure that you get some practice on each one of those.